If you're studying engineering, chances are welding is going to cross your path sooner or later. And trust me, knowing the basics isn't just helpful, it's essential. So let's break down the main types of welding, what makes them unique, and where you'll actually see them used in the real world. First up, we've got shielded metal arc welding, or SMA, but everyone just calls it stick welding. This method uses a consumable electrode stick coated in flux. When you strike an arc, that flux melts and shields the weld from air, keeping things clean. It's super versatile, great for construction sites, pipelines, and repairs out in the field because you can use it pretty much anywhere, even outdoors in the wind. Next is gas metal arc welding, or GMO, better known as MIG welding. Instead of a stick, you've got a spool of wire feeding through a gun, and shielding gas keeps the weld pool protected. MIG welding is fast, easy to learn, and perfect for joining thin materials. That's why you'll see it all the time in manufacturing and auto body shops. Now, let's talk about TIG welding, or gas tungsten arc welding, GTAW. Here, you use a non-consumable tungsten electrode, and you feed in a filler rod by hand. TIG gives you super precise control. Think aerospace, bike frames, or anything where the welds need to be extra pretty and strong. It's a bit slower and takes more skill, but the results? Worth it. Another big one is flux cord arc welding, FCAW. This is similar to MIG, but the wire has flux inside, so you don't always need a separate shielding gas. It's great for heavy-duty stuff. Think shipbuilding or thick structural steel. And it's reliable even in windy outdoor conditions. There's also submerged arc welding, or SAW. With this method, the arc is hidden under a pile of granular flux, which means minimal sparks and super deep welds. It's mainly used for big, heavy welds in industries like shipbuilding or making large tanks. And hey, let's not forget about oxyacetylene welding. It's old school, uses a flame instead of electricity, and is awesome for cutting, brazing, and repair jobs. Plus, it doesn't need power, just gas tanks. So, to sum it up, stick for versatility, MIG for speed, TIG for precision, flux cord for heavy-duty work, submerged arc for really big welds, and oxyacetylene for classic jobs. Each technique has its strengths, and knowing when to use which is a huge part of engineering success. Whether you're planning to weld bridges, bikes, or even robots, these fundamentals are your toolkit. So suit up, stay safe, and keep exploring, because welding is where science meets pure metal magic.